few questions. So I guess the quiz will be on Tuesday. Some people came in this morning asking about this problem. First of all, what the heck is a constant term? Yeah, no variables, only a number. So if I were to expand this, how many terms would there be? 10, there would be 10 terms, so just write all 10, whichever one doesn't have a constant box set. Yeah, you could, but doesn't every term going to be of the form 9 choose something? This is A, right? A to the something, and then here's B, right? B to the something, right? And then don't these two powers have to add up to 9? So how can you put the two powers in that add up to 9 so that all the x's will cancel out, so that then you don't have a variable? Is it like 9 and 0, 8 and 1, 7 and 2, 6 and 3, what? Yeah, it's 3 and 6. Because look, if you multiply this out, you're going to get x to the 6. Over here, you're going to have x to the 6 in the denominator, and you cancel out, right? And then, of course, whatever power you have on the b term, that's the number that's down here, right? There you go. That's your answer. Let me just simplify it. Or do you want me to simplify it? Just look at the answer at the bottom. That's how you guys get in trouble. Okay, I think you guys can take it from there. Okay, number 5E. Well, in order to, well, I even gave you a hint right here. Okay, before you can do 5E, you have to do 5B. So 1 minus x to the negative 1 for 5E, using the binomial theorem, is 1 plus x squared plus x cubed. So no, this is D. So in 5E, you have to do 1 plus x times 1 minus x. Well, isn't this the same thing as this right here? Right? So isn't this the same thing as 1 plus x times 1 minus x to the negative 1? Right? Then that's what this is right here. So it's just 1 plus x times, and then you just take your answer from D, which is 1 plus x squared plus x cubed plus ... And then you just do multiplication. How do you multiply polynomials? You take the first term and distribute it. Then you take the second term and distribute it. And then if you add them together, see how you line up all the like terms? What do you get? 1 plus 2x plus 2x squared plus 2x cubed plus ... Okay, so that's one way of doing it. The other way is, what does this bar mean right here? It means divided by. And do we know how to divide? Yeah, just do long division. So 1 plus x in the house divided by 1 minus x. 1 goes into 1 how many times? 1. Multiply it times the divisor, subtract. 2x. 1 goes into 2x how many times? 2x. Multiply it times the divisor, 2x minus 2x squared. Subtract. 2x squared. 1 goes into 2x squared how many times? 2x squared. Multiply that times the divisor. 2x squared minus, can you see what's happening here? Subtract. 2x cubed. 1 goes into 2x cubed how many times? 2x cubed, and it just keeps on going. And you get the same answer. Which way do you like better? I don't know, I kind of like the division way better, but that's just me. Okay, and then number 6. Didn't I show you an example like this yesterday? Boo! Okay, in fact, we did 5a. 1 plus x to the 1/2. Okay, look, taking your answer from 5a, 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed and so forth. It says use the first 4 terms to approximate the square root of 2. Okay, what do I have to plug in for x to get the square root of 2? 1, right? Because 1 plus 1 is 2, and 2 to the 1/2 power is the square root of 2, right? So all you have to do is plug in 1 for x. Wherever you see x, plug in 1. And there you go. That's an estimate of the square root of 2. Of course, you don't get exactly the square root of 2. You have to use all the terms, an infinite number of them. But once you stop, if you only use like 1,000,000 terms, that's just an estimate, right? Now, how good is this estimate? It says compute the percent error. How do we compute percent error? Okay, what is this equal to? Did you guys have at least compute this number here? Here, let me look at the bottom. 23/16. How good an estimate is that? So how do you figure out percent error? Actual minus whatever you get experimental, is that what you call it in chemistry? Divided by actual, and then multiply by 100 to get a percent, right? So just punch that in on your calculator. Okay. I'm not going to make you compute percent error on the quiz or test. Okay, so today's lesson, really easy. Inequalities. Okay, we definitely did this last year. Oh, we're going to finish early. We're going to talk about the test. Still got to talk about the test. Okay, what's the procedure for... Now, of course, everybody can solve linear inequalities, okay, but what about when you get higher power and rational inequalities? Well, the procedure is you make one side 0, you factor the other side, and then you test the number line. Yeah? So, here. Let's just assume one side is 0 already, and we know how to factor, right? Because we already studied synthetic division. What if you have this? X plus 2 times x minus 1 times x minus 3 is greater than 0. How do you solve an inequality like this? See how one side is 0 already and the other side is factored? Once you do that, you just make a number line. Is that, what did you guys do last year? Did you make number line or did you do the table of signs? That's what we used to do. Just make a number line, it's a lot simpler. Okay, put down the zeros on the number line. None of these are going to be part of the solution. Why? Because it's greater than 0. If it was greater than or equal to 0, then they would all be part of the solution, but they're not. Okay, and then you have 4 regions to test. I like to start over here. Think of a number bigger than 3. 4, plug it in. 4 plus 2 is positive. 4 minus 1 is positive. 4 minus 3 is positive. Positive times positive is positive. And then you just keep testing all the regions. Think of a number between 1 and 3. 2, plug it in. 2 plus 2 is positive. 2 minus 1 is positive. 2 minus 3 is negative. Positive times negative is negative. You guys did this last year, right? But then if you know things, then you can save time. Because if you think about the graph, isn't the graph going to look like this? This is why am I even drawing these things? Here's the x-axis. If you were to graph this polynomial, leading coefficient positive, odd degree, isn't it going to look like this? See, so the graph is above, below, right? So it's going to be plus, minus. If the graph is above, it's plus, right? The y-coordinates are positive. If the graph is below the x-axis, it's going to be negative. So what you can do is you can kind of visualize what the graph looks like, and then you don't even have to test. Or how about this? Once you figure out this one, see, 3 came from this factor, it has an odd power. Why does it have to change if you have an odd power on the factor? Yeah, because what did we learn? When you have an odd power on the factor, doesn't the graph go through the x-axis? It goes through, so it has to change sign, right? Okay, and then 1 came from this factor, has an odd power, so you change. Negative 2 came from this factor, which has an odd power, so the graph is going to go through again, so it changes. So there's lots of ways of getting it. You want to get it the fastest way possible. Okay, let's put some powers on here and see what happens. Let's make greater than or equal to 0, and let's put a square on one of these. Which one? Pick one. Okay, put a square there. Okay, so if one side is not 0, you got to make it 0 now. And if it's not factored, you have to factor. You got to use synthetic division. Use synthetic division. Okay, so -2, 1, and 3 go on the number line, and they are all part of the solution, correct? Because 0 is greater than or equal to 0, right? Okay, now, this is what I do. I like to pick this one because whenever you pick a number bigger than 3, like 4, positive times positive times positive is positive. Okay, 3 came from this factor. It has an odd power, therefore it's going to change, right? 1 came from this factor, it has an even power, so whatever you have here, it's got to have the same thing because the graph is going to bounce off, that's why, right? -2 came from this factor, odd power, so it's going to change. Anyway, like I said, if you don't know anything, just plug in a number in between there, right? You don't have to know any shortcuts. And we're looking for greater than or equal to 0, so then you shade in the plus sign, yeah? And then of course, then you gotta write down your answer. So, I don't care how you write, you can write your answer like this. X is less than or equal to -2, or X equals 1, or X is greater than or equal to 3. Or if you want to write interval notation like your book last year, you can go -infinity to -2, including -2. How do you write a single point? Well, the interval from 1 to 1, including 1, and then 3 to infinity, including 3. So you can write your answer either way. I write mine whichever way I feel like at the time. You guys know the difference between or and union though, right? They mean the same thing, but you have to use the word or between statements, and you use the union between sets. They mean the same thing though. Okay, let's look at rational kind. What if you have a rational one? Again, let's assume we can make one side 0. And let's say we have a rational function here. X plus 2, x minus 1, x minus 3, x plus 1, and let's put some powers on here. Put a 2 on this one, and a 2 on that one. Okay, whatever. Okay, so this one is easy. It's made to order. One side is 0, and the other side is factored. Because for most of you, the hard part is getting it to this stage right here. Okay, so what numbers go on the number line? Numbers that make both the top and the bottom 0. So you're going to have -2, -1. Please put them in order. Every year there's always 2 or 3 clowns. They just put the numbers in any order they want. And they wonder why they get a fatal error. Okay, is -2 going to be part of the solution? Yeah. Yes. Because if you plug in -2, you get 0 is less than or equal to 0, which is true. What about -1? No, because it's in the denominator. The denominator can't be 0. What about 1? Yes, and 3, no, because it's in the denominator. Now, it doesn't matter where you start. I always like to start here because if you plug in a number bigger than 3, you get positive times positive divided by positive times positive, which is positive. Oh, Mr. Park, is the right one always positive? No! Only when the leading coefficients are positive. Right? And they are, so it's positive. Anyway, 3 came from this factor. It has an even power, so it's going to stay the same. 1 came from this factor. It has an odd power, so it's going to change. -1 came from this factor. It has an odd power, so it changes. -2 came from this factor. Has an even power, so it stays the same. And like I said, even if you don't know the shortcut, right? Just plug in numbers in between. And we're looking for less than or equal to 0, so we're going to shade in the minus. And then whatever you see on the number line, that's your answer. So, x equal -2, or -1 is less than x is less than or equal to 1, or, no, that's it. That's your answer. That's nothing else. Or if you want to write interval notation, -2 to -2, including -2, union, -1 to 1, including the 1, but not the -1, like that. You guys know, right? Parentheses means it doesn't include, and bracket means it includes, right? Oh, this is easy. Yeah. Okay, but now, what happens if it's not tailor-made? Like this. What if you have x cubed plus 11x is less than 6x squared plus 6? What should I do? I just told you, make one side, always make one side 0. You don't even think about it. So make one side 0. Okay, and then you gotta factor the left side. And when it's third power or higher, do we know how to factor that? Yes, it rhymes with synthetic division. Synthetic division! That's why we learned it. Why do we learn things so we can just forget it the next chapter? That's what happened last year, but it's not going to happen anymore. Come on, when you go to calculus next year, you got to know everything. Okay, so what number should I try? Factors of 6 over factors of 1. Okay, 1 would be a good. Can you see 1's going to work?
Sorry.
What the heck is that?
Oh, Siri.
Who?
Siri.
Who's Siri?
The vocal command thing on the phone.
And what does it do?
You can say stuff to it, and it does stuff for you.
But it's saying things to you, though.
I think I accidentally hit the button.
Anyway, can you see that 1 works? Do you guys even understand that? Look, if you plug in 1 for x, you get 1 minus 6 plus 11 minus 6. Is that 0? Yes, 12 minus 12 is 0. That's why it works. Some of you go, I don't know what you're talking about. See? X minus 1, and then you look at this. That's x squared minus 5x plus 6. Can that be factored some more? You bet your sweet pippy you can. And so you go blah, 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 and less than 0. Now we got it to the form. So, woo! So once you get here, this is just easy already. Boop, boop, boop. How do I know without even thinking it's going to be plus, minus, plus, minus? How do I know they're all going to alternate? Because all odd powers, and how do I know it's going to be minus, plus, minus, plus? Because the one over here is going to be plus because the leading coefficient is positive. Or just think of the graph, right? See, if you think of the graph, then over here got to be positive, and then over here got to be negative. And then less than 0, we shade it over there, and I think you can write the answers from there. See, so the hard part is going to be getting it into that form. One side is 0 and the other side is factor, okay? Let's kick it up another notch. How about x plus 1? I wonder if this is going to come out. Maybe not. Who cares? If it comes out ugly, it comes out ugly. Okay, solve this inequality. What should I do first? Multiply both sides by x minus 2. Get rid of the fraction. Why not? Well, I'll tell you what. If you did multiply both sides by x minus 2, that's a fatal error. Minus 8. On the spot. How come I can't multiply both sides by x minus 2, Mr. Burt? Because this is an inequality. When you multiply both sides of an inequality by a negative number, then what? Remember what has to happen? Then you got to change the inequality. If you multiply both sides by a positive number, then you leave it the same. We don't know what x minus 2 is. Sometimes it's positive, sometimes it's negative. So if you want to make 2 cases, one where it's positive, one when it's negative, you can, but that takes too long. So how do I make one side 0 then? You bring the x over. Do not make up your own. You make up your own, that's how you get fatal errors. Now, if you wanted to multiply by both sides by x minus 2 quantity squared, you could. You know what I'm talking about? Because x minus 2 quantity squared is always positive, that's why, right? So that you can do, but you can't multiply by x minus 2. Okay, now what? Now you have to factor the left side. How do I factor when you get fractions? How do I subtract fractions? Least common denominator. Oh no! See, if it's not tailor-made, it takes a lot of algebra just to get to the step where you can make the number line. So, and please be careful here. Don't forget to put the x minus 2 in parentheses there because you got to distribute the negative x. So you're going to get x plus 1 minus x squared plus 2x all over x minus 2 is less than or equal to 0. Actually, if it comes out ugly, it might be better for you. Okay, simplify the numerator. Negative x squared plus 3x, yep, it's ugly, plus 1, all over x minus 2 is less than or equal to 0. Now watch what I do. Now you don't have to do this, but this is what I do. X squared minus 3x minus 1, all over x minus 2 is greater than or equal to 0. What did I just do? How did I go from this step to this step? I divided both sides by negative 1. But then when you divide by a negative number, you got to change less than to greater than. Why do you do that, Mr. Park? Because I want my first term positive. Some of you still making the first term negative and you're running into all kinds of trouble. Does this factor? No, it doesn't. If it factored, I would have factored it. It doesn't factor. So now you're going to have to use quadratic formula. Now we are ready for the number line. What goes on the number line? What makes the top or the bottom 0? Well, obviously 2. What about the top? You're going to use quadratic formula. 3 plus or minus the square root of b squared minus 4ac. Uh-oh. B squared. Is that root 13? All over 2? Did you do that correctly? Of course, I'm the teacher. So 3 plus root 13 over 2. Okay, now, where do I put 3 minus root 13 over 2? Is it over here or over here? Is it bigger than 2 or smaller than 2? Well, what is root 13? 3 point something? What is 3 minus 3 point something? Negative point something divided by 2. I think it's over here then, yeah? Just keep staring, yeah? And then these two are going to be part of the solution because these two numbers make the top 0, but that one is not because it makes the denominator 0. If a number makes the denominator 0, that cannot be part of the solution. And how do I know without even thinking it's going to be plus, minus, plus, minus? How do I know? Yeah, but Mr. Park, I don't see any factors. Yeah, but see, isn't this the same thing as x minus 3 minus root 13 over 2 and x minus 3 plus root 13 over 2? That's what it is, except it's all ugly, right? So see how they have odd powers on it? So everything's going to alternate. And so we're looking for greater than 0, so it's boo, 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 and boo, 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 boo. Well, there you go. That's your answer. Then you just write it down. Okay, so on Monday, we're going to learn about absolute value now. In order to do absolute value, you got to be proficient at doing number lines now. Otherwise, you're going to be lost. Because absolute value, what do you guys know about absolute value? Just make it positive. Although some of you don't, yeah? Remember, the distance between a point and a line, get the absolute value, but you still make them negative. No! No, I'm serious. What do you guys know about absolute value? Oyana Mari. That's what I just told you. Make me break my chalk. If that's all you know, just make the answer positive, then we don't know anything. No, I'm serious. What did you learn about absolute value? Qua. Okay, we'll just wait till Monday for that, right? Okay, we got 20 minutes left. Okay, I'm not going to pass out the test again, but I'm just going to go over a few things because they're super important. I wanted to write everything on the board, but it took too long this morning. Oh, I gotta turn off this, otherwise, whoa, I almost fell into your web of deception.